Welcome. Today we are going to continue on with our naming of binary compounds, and today we are going to talk about binary molecular compounds. So, if we remember back to what we mean by a molecular compound, right? That's simply a compound that exists as individual molecules, right? And these are going to be compounds that are composed of two or more nonmetals. So, unlike ionic compounds, which we saw in the last video, right, there's going to be no metals involved here, right? So we're just looking at two or more nonmetals. Now, unlike ionic compounds, where we had the advantage of being able to write out the formulas really just from knowing what elements are involved because of the ions that are present, right, and understanding what ions different elements form, we can't do that with a molecular compound, right? We can't readily write out the formula just from the elements because we don't have any place to really start with how many of which element will come together, right? And in fact, they can form many different forms, right? The same elements can come together in different ways. And so, really, the only way that we can write out the formula for a specific molecular compound is from the name. So, naming it correctly becomes very important. Right? And so, just to give sort of an example, right, if I put nitrogen and oxygen together, they can form all of these different unique compounds, right? NO, NO2, N2O, N2O3, N2O4, N2O5, etc. Right? So, a bunch of different compounds, right? So how do we name these effectively in a simple, easy to keep track of way? So before we do that, one other thing I want to talk about is sometimes it comes up, the question is, why do we write the elements in the order that we write them in a compound, right? In a molecular compound. So why is N before O, etc.? So while there are exceptions, for the most part, we always write elements that are further left first, and also elements that is lower in periodic table first. So essentially we write the lowest lowest to left element first. So for example, nitrogen is further to the left, so it becomes first in our compound. If we have two elements in the same group, say S and O, right? S would be written first because it's lower in the group. Right? So that's just the basic rule of thumb, where elements that are further to the left and lower in the periodic table are written first. So, things like carbon and phosphorus and nitrogen, right, will often appear beginning. Oxygen will almost always be, second or later in the formula because of its position on the periodic table. Okay, so that's sort of the rationale for why they're written in the order that they are. So how do we go about doing this? Well, we use a system of what are called prefixes, right? So prefixes are going to be these words that will stand for how many of that particular element we have. So the basic formula is we have the prefix to stand for how many of the first element in the name that in the formula that we have. And the second part is the prefix for the second element. Remember, these are binary, so two elements. So the prefix of the second element of how many we have, and then the name of the second element. And notice, to distinguish it, the second element, again, ends in IDE, just like we saw in the ionic compound. So one commonality between ionic naming and molecular naming is they will mostly end in IDE. So prefix, element of the first name, a name of the first element, prefix for the second element, name of the second element, ending in IDE. So first thing is you have to make sure you know the prefixes, right? So 1 through 10, you won't go above 10. In fact, mostly you won't go above 8. Doesn't get terribly common. But we need to understand, mono, di, tri, tetra, penta, hexa, hepta, octa, and then nona and deca. Now, the only time that we will not use a prefix is if the first element, the first prefix would be mono. So if this one here was going to be mono, we would normally drop it, right? So, simple example, right? If I have CO2, right, we know this as carbon dioxide, not monocarbon dioxide. Right? We cut off the first element if it's going to be a mono, right? If there's no prefix at the beginning of a molecular compound name, we assume that there's only one of that first element. So if you can remember that, then we can start to name molecular compounds. No, there are a few other sort of grammatical things that we'll see that along the way. For example, there are certain vowel combinations where we tend to drop a vowel. For example, if we have an AO combination or an OO combination, we tend to drop it. So if we had tetraoxide, right, instead of being tetraoxide, tetraoxide, it would be tetroxide. We would drop the A, right? If we had monooxide, right, we would drop one of the O's, right? So we have that OO or AO combination. We'll drop the first vowel. Now, those are sort of subtleties, right? That it's not technically wrong if you don't do it, but it's the common way that we want to get better at naming these things. So let's do some examples. So we'll start with naming a few of those nitrogen-oxygen compounds so that we can see how those, we can tell those apart. So if we have the formula NO2, so we look at the first element, we have one of them, so it would be a mono. Now remember, we drop the mono, so the first element here just becomes nitrogen. We look at the second element, we have two of them, so that's a di. And we have oxygen, so it's dioxygens, but we're going to end in IDE, so it becomes dioxide, or nitrogen dioxide. And we go down to the second one, right? So here we have two of the nitrogens, the first element. So we have a di and nitrogen, right? So we always use the full name of the first element. And we have one of the oxygen second. So we are going to use a prefix, right? Because it's the second element. Now it's monoxide, but remember, we typically drop one of those O's, so it becomes monoxide. So it becomes dinitrogen monoxide. The second one, second, look at the first element, we have two of them. So it's dinitrogen. We look at the second element, oxygen, we have four of them. So it's a tetra. So remember, so we have an AO, so we're going to drop the A. It's going to be tetroxide. Now, if you write tetroxide, again, not a huge deal at this point, but as we get better at these, we'll learn those little subtle distinctions. So let's try something else. So first element here, I. So that's iodine. We have two of them. So it's a di. So it's diiodine. Now notice with the II, we keep both of them. Right? Sounds better that way. Diiodine. We have the second element. We have 5 of them. It's again an oxygen, so it's penta and an oxide. So again, an AO, so it's going to be, instead of pentaoxide, it's just pentoxide. So diiodine pentoxide. Right? So it's a formula that has 2 iodines, 5 oxygens. Right? That's the idea. So using these prefixes in molecular naming becomes the key. Now, we also, of course, in any of this naming, we need to be able to go both ways, right? So if we have an ionic compound, if I have the name sodium chloride, I need to go be able to back and write, oh, that's NaCl is the simplest way to write out that, so the combination of sodium and chlorine. Same thing with molecular compounds. I need to be able to look at the name and bake that back down to the formula. So again, it's pretty simple as long as we understand what the prefixes mean and what the names are, right? So first part, I have diboron. Well, I know boron, that's B, right? And there's 2 of them, so I have B2, and I have chlorine, and I have tetra, so I have 4 of them. So I have B2, Cl4, right? Diboron, tetrachloride. Xenon hexafluoride. So we've got xenon, right? No prefix here, so we have to assume that means there's 1 of them, right? That it would be a mono. And hexa, 6, and fluoride, so 6-fluorine, so F6, so XeF6, xenon hexafluoride. Yes, we need to be able to go back and forth. So now that we've learned how to name both molecular and ionic compounds, and we know much more about the formulas, right? We're going to introduce the term formula mass, right? So last chapter we learned the term atomic mass, right? Or average atomic mass, right? Which was the mass of an atom of an element expressed in atomic mass units. Well, formula mass is the same idea, but for a compound, right? So this is the mass of individual molecule of a compound right? Now, I do have to make a little distinction, right? It's the mass of an individual molecule, or, right, this could be or a formula unit if we're talking about an ionic compound, right? So this definition would apply to both individual molecules of a molecular compound or formula units of an ionic compound. And of course, this is going to be in units of AMUs, just like atomic mass. Now, you may also have heard of this called molecular mass or molecular weight. Those are just different sort of terms for the same thing. This book uses formula mass, that's sort of the more technical name for this idea. Now, the way that we get this is we simply sum up the atomic mass of all the elements. Right? In the formula. So the formula mass is going to be simply the atomic mass of the first element, of course, multiplied by however many of that element we have. So if we have multiples of an element, we have to, of course, take that into account. And we just add that to all of the elements. So we just essentially take the mass of all the elements in our formula and we add them up. So, for example, the formula mass for water, for H2O, is going to be the mass of 2 hydrogen atoms plus 1 oxygen atom. So, for hydrogen, right, we have 2 times 1.01 AMU, right? And these are just the masses that we pull off the periodic table. Plus, for oxygen, we have 1 times 16.00 AMU, which gives me a total of 18.02 AMU. And that's going to be the formula mass or molecular mass of water, right? So that's the mass of 1 molecule of water in units of AMUs. Okay? So it's the analogous for atomic mass for compounds. So that wraps up our discussions of Chapter 5. So in our next segment, we will be moving on to Chapter 6 and talking about how we work with formulas, right? How can we now take what we know about these formulas of compounds and work with them?